In this video, we'll look at evaluating logarithms. So I have a bunch of logarithm things to solve. We'll solve them. Question 1. Log 3 root 27. Well, first we're going to change that root to an exponent. Please watch videos on exponents if you're not sure what I'm about to do next, which is square root is the same as exponent of a half. So I'm going to change this to 27 to the power of a half. Next step is I know log base 3, and I want to have 27 and make it a base 3. So 3 to the power of what is 27? Well, 3 to the power of 1 is 3, so it's not that. 3 to the power of 2, that's 9, so it's not that. But 3 to the power of 3 is 27. So I could change this inside the brackets to 3 to the power of 3. The half's still on the outside. And now, before I can do anything with this log, I got to remember to first put these exponents together. When you have an exponent with an exponent on it, you multiply the exponents. So what's 3 times a half? You get 3 to the power of 3 halves. Alright, now we're in business here. We have a couple ways we could go. One rule we have with logarithms is when you have the same base here, when you have any exponent, you can put the exponent out in front. As long as everything's one base. I couldn't do it before where there were two exponents, but now I got one base, one exponent. I can pull the exponent out in front, and I just get log 3. And we have a rule, when you log a number with the same base, that just equals 1. And what's 3 halves times 1? Just 3 halves. What I started to say earlier is we also have another rule that when you log the same base, so the log of 3 to the same base, you get the answer is just the exponent. And I've demonstrated why here. As in, you could have gone right from here to here because we have a rule, log of any base with the same exponent base gives the answer is this exponent. That's question 1 done. Question 2 says log 5x equals 3. I'm going to convert this to an exponential to solve it. The base is 5. The exponent is 3. And the answer is x. That's how you convert logarithms to exponentials. And now it's a piece of cake. What's x equal? 5 to the power of 3. You can pull out your calculator, but some of us can do it in our heads. No judgments. 5 to the power of 3, you get 125. Third question is log x, the base is x, to the 1/4 equals -2. Again, I'm going to change that to an exponential. So this time the base is x, the exponent's -2, and the answer is 1/4. A little bit trickier to solve here. I want to get x by itself. But first I'm going to raise it all to the power of -1. Means I'm going to raise this to the power of -1. Because when you do an exponent on an exponent, look what happens. Exponent on exponent, you multiply them, you get x squared. So that negative's gone. And what happens, please watch videos on exponent rules, what happens when you do a negative exponent on a fraction? Negative exponent means flip me over the line, change my exponent sign. So flip me over the line, change my exponent sign. So x squared just equals, what's 4 divided by 1? 4 to the power of 1 is just 4. And now how do you solve that? Easy. What's the opposite of square? Square root. But a plus or minus square root. When you're undoing a square, you have to plus or minus square root. So you get x on the left, on the right, what's the square root of 4? 2. So you get plus or minus 2. Except that you can't have a logarithm base that's negative. So I'm going to write, but x equals -2 is inadmissible. Can't have a negative base for logarithms. Inadmissible. Inadmissible. I forgot an I there. I squeezed it in. So x equals 2. And you can sub in and check log base 2 to the power of -2. It might be easier to look at our exponent one. What's 2 to the power of -2? Try it on your calculator if you want. When you do 2 to the power of -2, what do you get? You get 1/4, which is what the question was. 2 is our answer. 2 to the power of -2 is 1/4. We got it. Last one is just a nice rule one. This was the rule I was talking about in question 1. When you have log m to the base m exponent n, you can bring the exponent in front if you want, and then you get log m and we have a rule that just says log mm is equal to 1, so you just get n. Or you can use the rule which jumps straight to the answer. That is, whenever you log the base is m to the same base of the exponent, the answer will just be whatever this exponent is. And that's some questions on how to evaluate logarithms.